So, you want to level up your Python skills, right? Go from just writing scripts to building real, professional software? Well, to do that, you absolutely have to master object-oriented programming. And sitting right at the heart of it all is one crucial concept: inheritance. In this explainer, we're going to break down exactly what it is, how you use it, and why getting this right is your ticket to acing that next technical interview.
Okay, so let's kick things off with a big question. I want you to think about these massive code bases. You know, the kind of stuff that powers big tech companies or complex back-end systems. How on earth do professional developers manage all that complexity without just copying and pasting code everywhere?
Well, the secret weapon they all use is a fundamental principle of object-oriented programming, and it's called inheritance. This is the magic that lets them write code that's clean, that can grow and change easily, and that's super efficient, and we're about to dive right in. Now, inheritance isn't just some abstract academic thing. No way. It actually gives your code some serious superpowers. You get to reuse code you've already written, which means less typing and fewer bugs. It lets you add new features without breaking your old code, and it helps you build a really clean, logical system that follows the #1 rule of good programming: don't repeat yourself.
All right, so what is this inheritance thing really? Let's strip away all the jargon and get right into the core idea, and I promise it's simpler than you think. You know, the easiest way to think about this is, well, it's just like real life. A child class can inherit traits, or in our case, properties and behaviors, from a parent class. This means the child class just automatically gets all the parent's functionality for free without you having to rewrite a single thing. Okay, check this out. It's a super simple but perfect example. Let's say we have a general animal class, and all animals need to eat, right? So we give it an eat method. Now, when we create a more specific dog class, we can just say it inherits from animal. And boom, the dog class now knows how to eat. You don't have to write that logic again. That is code reuse in action. Okay, now we're getting to the part where honestly a lot of beginners get stuck, but we're going to make it super clear. How do we actually make that connection between the child and the parent work properly? The key is a handy little function called super. So here's the trap. This is the thing that catches everybody at first. Let's say your parent class has its own little setup routine, that special __init__ method. You might think the child class would just run that automatically, but it doesn't. And that can cause some really strange bugs if you're not paying attention. This slide shows it all, the before and after. On the left, you've got the problem. The child's init is totally ignoring the parent's setup. The connection is broken. But on the right, bam, we fix it with one simple magical line. Super.init.init. That one line creates the bridge and tells the child, hey, before you do your own thing, make sure you run our parent's setup first. So, if you remember one thing about this, remember this. Super is that essential bridge. It's the official handshake between the child and the parent. It guarantees everything gets set up correctly, all the way from the top of the family tree down to the bottom. But here's the cool part. Inheritance isn't just about blindly copying everything. A child class can look at a method it got from its parent and say, you know what, I have a better, more specific way to do that. A generic animal might just make a generic sound. But a dog goes woof. That's called method overriding. It's all about specialization. Okay, so we've got children inheriting from parents, and they can even change things up a bit. This leads to all sorts of different family structures, right? Let's take a quick look at the different patterns you're going to see out there in real code. First up, the most common, the one you're going to use 90% of the time, is single inheritance. It's exactly what it sounds like. One parent, one child. Our animal class having a dog child is a perfect example. It's simple, it's clean, and it's incredibly useful. But what if we want to go deeper? You can. That's multi-level inheritance. It's like a family tree going down the generations. You could have a poodle that inherits from a dog, which in turn inherits from an animal. Each level gets more and more specific. Then you've got the opposite situation. This is hierarchical inheritance. Think of it like one parent having a bunch of different kids. That same animal class could be the parent to a dog, a cat, and a fish. They all share the basic animal stuff, but each one goes off and does its own specialized thing. And now, for the one that makes Python, well, really special, and sometimes a little tricky. We're talking about multiple inheritance.
A single child class can actually inherit from 2 or even more parent classes at the exact same time. It's super powerful, but it also raises a very important question.
And that question brings us to a really important topic. Understanding this, the method resolution order is what truly separates the beginners from the pros. Seriously, this is the stuff that interviewers love to ask about to see if you really know your stuff. So let's set the scene. You have one child class, but it has 2 parents. And what if both parents have a method with the exact same name? Uh-oh, when you call that method on the child, which one gets used? Who wins the tie?
This classic headache is known as the diamond problem. But don't worry, Python isn't just going to guess. It has a super clear, predictable rulebook for this exact situation. It's called the Method Resolution Order, or MRO for short. Think of it as a search path that Python follows every single time. So how does Python figure this out? It follows that MRO path, and it's always the same. Let's trace it together. First, Python looks in the child class itself, D. If the method isn't there, it moves to the first parent you listed, which is B. Still no luck? It then checks the second parent, C. Only after it's checked all the direct parents does it move up to the grandparent, A, and then finally to the base object class that everything in Python inherits from. It's a clear, predictable order, so there's never any confusion.
All right, that was a lot of theory. But theory is useless if we can't apply it, right? So let's look at how all these ideas come together in a practical example, something you might actually build in a real job.
Okay, check out this payment system. This is a super common pattern you'd see in a real back-end job. You'd start with a base payment class. It handles all the common stuff, like the amount and the transaction ID. Then you create specialized child classes, like credit card payment and PayPal payment. They both inherit that common logic, but each one overrides the main process method to handle its own specific details. It's a perfect, clean, and easy-to-extend design.
And look, I really want to drive this point home for your career. This quote right here says it all. You can't just memorize the syntax for class and super. That's not enough. You have to understand the why. Why does it work this way? How does Python solve problems like the diamond problem with MRO? That deeper understanding is exactly what interviewers are looking for.
So there you have it. We've gone from the basic idea all the way to the pro-level stuff that trips people up in interviews. You now have the knowledge to not just use inheritance, but to truly understand it. So the only question left is, are you ready to get out there and start writing some cleaner, more powerful, and way more professional Python code?